Actually, we know that the resistance of a conductor is equal to rho L by A. This is a very common formula for resistance. Now, this rho is nothing but it is called constant of proportionality. Another name is resistivity of the material. So we can say that resistivity is nothing but it is constant we are using in this formula. But actually this constant is a very important physical quantity associated with current electricity. Let's take its definition. How can we define resistivity? Now from this formula, if we take again this formula, and we can say that rho is equal to RA by L. Now let us suppose if L is equal to unity, area is also unity, then after putting we will get rho is equal to R. Rho is equal to R. What does it mean? Can we say that the resistivity is nothing but it is resistance but under certain conditions? What are the conditions? Condition number 1, if length of the conductor is 1, area of the conductor, area of cross section of conductor is equal to 1. In that case, the resistance of material is its resistivity. Now, if we take any conductor having length 1 and area of cross section is also 1 unit. The very simple example we can take of cube. Suppose I have iron material, मैंने उसका एक cube बना दिया. The side of cube is unity, that is 1. And what is area? Area is equal to length into length, side into side, that is again 1. Now, finally we can say that resistivity of a cube of a material of side 1 unit. That is called resistivity. So what is the final definition? That is, resistivity of a material is defined as the resistance of a cube of a material having side 1 unit. So this is the general definition of resistivity. Now let's take its SI unit. Now rho is equal to RA by N. What is our resistance? What is unit? Ohm. Area meter square. Length meter. Finally we will get that is ohm meter. This is called ohm meter. Now, so this is SI unit. Now let's take the factors on which the resistivity of material depends. Factor number 1. It has been observed that the resistivity of different material is of different value. For example, if I am taking copper and iron, it has been observed that the resistivity of copper is lesser and the resistivity of iron is little bit larger. It means that the resistivity depends on the nature of the material. Second very important quantity is temperature. Resistivity of material may vary with respect to temperature. Means if we are increasing the temperature, the resistivity of the material also changing. It depends upon material, which type of material we are taking. For example, I am taking case of conductor. If I am taking case of conductor, then what happens to the resistivity of the conductor if we are increasing the temperature? Experimentally it is proven that, for example, I am taking copper wire and current is flowing through the copper wire, and after some time the temperature increases. Now the resistivity of the copper wire increased. Now, is there another way to write the formula for resistivity? Yes, there is. we know that R is equal to ml upon ne square tau into A. This is another form of resistance by using the concept of drift velocity relaxation time. So from this we can derive another formula for resistivity, which tells about the factors on which actually resistivity depends. Now we know that what is R? R is equal to rho L by A. Now rho is equal to R into A divided by L. Now putting the value, we will get rho is equal to R, that is ml upon ne square tau into A. This is value of R, and this is A by L, this is A and this is L. Now area L. What is the final value? Final value is equal to m upon ne square tau. This is the another formula. Now from this formula it is very clear that there is no L, there is no area, means dimensions are not there, means it tells that the resistivity of material does not depend upon length of the material as well as the area of the material, area of cross section of that material. It is free from that. Now from this formula it is clear that resistivity of material depends upon n, that is number density of charge carrier, and it depends upon relaxation time. You can see here. Now n and tau depends on the temperature. In some material n will be increased, like semiconducting material. With rise in temperature, number of charge carrier, either holes or electrons, they start increasing. Similarly, if temperature is increasing, relaxation time, that is the time between two successive collision, is also going on changing. So ultimately what is the result? That resistivity depends on temperature and nature. It does not depend upon the dimension of the material. So this is all about resistivity. Sometime question asked about variation in resistivity and resistance. If the length of the wire is increased twice, what change will be in the value of resistance and what change in value of resistivity? Now question will be clear. What will be the answer? That is, resistance depends upon length. Therefore, if we are increasing the length of the wire, the resistance will be doubled. Now next we are taking conductivity. Conductivity, as the name suggests, it is written as this way. It is very simple. We know that conductivity is more, it means that the flow of the charge carrier is very easy from the material. So therefore conductivity tells about how much efficient a conductor is for flowing of current through it. It is simple. Resistivity is reverse of, conductivity is reverse of a reciprocal of resistivity. Now this is m upon ne square tau, which is equal to, that is ne square tau upon m. Again conductivity depends upon n, conductivity depends on tau. Again conductivity does not depend upon, that is length and the area. So we can say that like resistivity, conductivity also depends on the value of n as well as tau. It means that the value of n and tau also depends on temperature. That's why we can say that the conductivity also depends on temperature. Now, for metals, if we are taking, the conductivity is inversely proportional to temperature. Very simple. Similarly, for example, copper. अगर मैं copper wire लेता हूँ and we are plotting this graph, conductivity versus temperature, the conductivity starts decreasing. It means that now the flow of electron or charge carrier through the copper is not easy. So that's why resistivity and conductivity are reciprocal to each other. Now, what will be the units of conductivity? Very simple. Unit of resistivity is ohm meter. Now it become, that is ohm inverse meter inverse. Simple. Ohm inverse meter inverse. So this is a very small idea about conductivity. Hope you understand the difference between these two. Next, we are taking again a very important concept of mobility. What do you mean by the mobility? We know that whenever we are taking any type of conductor, the current through the conductor always flow in form of charge carrier. For example, metals. In case of metal, the charge carriers are free electrons. They are free electrons in case of metal. Now, this mobility is a physical quantity which is associated with this charge carrier. In a very simple definition, we can define it as mobility of a charge carrier is the drift velocity acquired by it in unit electric field. For example, this mobility is denoted by mu. According to mathematical form, mu is equal to the drift velocity acquired by charge carrier when unit electric field is applied to it. It's called mobility. Now, the charge carrier in different types of materials are different. For example, in case of metals, free electrons. Metals. In case of metals, free electron. In semiconductor, these may be electrons and holes. We will discuss in coming chapters. So how much easily charge carriers flows through any material is associated with this mobility. Very important. Now, what are the units of mobility? Very simple. We can find out the unit. What are the units of VD, that is drift velocity? Very simple. That is meter per second. What are the units of electric field? That is volt per meter. Volt per meter. Now, finally, it become meter square per volt and second inverse. This is SI units. Sometimes SI units may be asked in the examination. Now, there is a question sometime asked, what is the relation between current and mobility in case of a conductor? In case of conductor, relation between mobility and current in case of metal और conductor की हम बात करें, metal और conductor. Because in metals, free electrons, that is free electrons are the charge carrier. So we can say that, let us consider mu E is the mobility of free electrons. Let us consider I be the current. Now we know that, very important, NEAVD, this is drift velocity. Drift velocity. This is equation number 1. That is, what is mu? Mu is equal to drift velocity per unit electric field. So this implies that what is Vd? Drift velocity is equal to mu time E. Therefore, by putting this, I is equal to N, we can put E A. What is Vd now? Vd is nothing but it is mobility of electron into electric field. So this is the expression. So this is the mobility. Sometimes dimensional formula of mobility will be asked in examination. Now next